Hi, we're going to get into section 3.3 out of chapter 3. This is temperature, and we're mainly going to be looking at temperature conversions. So I'm going to show you how to show your work and then how to use the calculator. So we typically use Celsius in science, but here in the United States, of course, we use Fahrenheit. So we will, in the lab, collect temperatures in Celsius. But still, it's nice to know how to convert between Celsius and Fahrenheit. Celsius was built on water. Water freezes at 0 for Celsius. Water boils at 100 for Celsius. Fahrenheit was not built on water, and so water freezes at 32 degrees Fahrenheit for freezing, and then for boiling, it's at 212 degrees Fahrenheit. We can convert from Fahrenheit to Celsius by using that equation. TF, that's the temperature in Fahrenheit, TC is the temperature in Celsius. Let's do an example. Task 3.1. Room temperature is around 75 degrees Fahrenheit. Convert that temperature to Celsius. So let's see how we would do this. The first thing we want to do is record everything that we know. We have the temperature in Fahrenheit of 75 degrees Fahrenheit. We want the temperature in Celsius. So there, I've identified my variables. The equation I'm going to use is temperature Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. Let's fill in every information that we know. The temperature Fahrenheit is 75, 1.8. I don't know what the temperature Celsius is. I'm going to put an X in there. Typically, I would leave T sub C, but in this case, I'm going to show X. And then we're going to add 32. So now we have to use our algebra skills. The first thing I'm going to do is I'm going to subtract 32 from both sides. So let me bring in my handy dandy calculator. And I'm going to put that right there. And it disappears. There we go. So I'm going to take 75 minus 32. Move this up a little bit. Sorry. First time using a calculator on the screen here. So we got 75. Oops. So 75 minus 32. And we get a value of 43. So I've got 43 is equal to 1.8 times x. Algebraically, my next step is to divide by 1.8. So I'm going to divide both sides by 1.8. So now I'm going to hop into my calculator, and I've got 43. So I'm going to hit divided by. A and S means answer. So that's going to use my answer from the previous calculation, which is 43. So I'm going to divide by 1.8. It did not divide by 1.8. Sorry. Divided by 1 point. It's lagging a little bit. 8. There we go. Now we're going to get the right answer. So that means my x is equal to, it disappeared on me again, 23.8 repeating. We're going to get into significant figures. Right now we don't really care. So I'm going to round it to 2 decimals. So that's 23.89. Okay. I found the temperature in Celsius, so that's degrees Celsius. So that is my T sub C. Okay, so there's one example for you. Let's do the reverse. The melting point of beeswax is 62 degrees Celsius. Convert that temperature to Fahrenheit. So what do I have? I have the temperature in Celsius, and I know that it's 62 degrees Celsius. I'm looking for my temperature in Fahrenheit. Look at my equation. My equation is temperature Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. Okay, let's plug in everything that we know. We're looking for the temperature Fahrenheit, so we don't know that. Last time I made that an X. This time I'm going to leave it as temperature Fahrenheit. 1.8, my temperature Celsius is 62 plus 32. This one seems to be a little bit easier of an algebraic problem. So let's bring my calculator back in. I've got 1.8 times 62. And I get a value of 111.6. Now, to that value, I'm going to add 32. So again, if I hit plus, notice answer comes up, so that's using 111.6, so plus 32. So I get a value of, for my temperature Fahrenheit, 143.6 degrees Fahrenheit. So there's an example of Celsius. There's an example of Fahrenheit. There's another temperature scale that we need to talk about. The Kelvin scale. Celsius is based on water. Kelvin is based on the movement of atoms. So the coldest possible temperature is 0 Kelvin. That's what's called absolute zero. The reason why it's called absolute zero is that is the coldest possible temperature. And that's defined as when the particles stop moving. Now, you can see at 0 degrees Celsius, temperature in Kelvin is 273. And at 100 degrees Celsius, the temperature in Kelvin is 373. So here is our equation to convert from Kelvin to Celsius. And you can see that a change of 1 Celsius degree is equal to a change of 1 Kelvin. It's not 1 degree Kelvin, it's 1 Kelvin. Let's try some conversions. The boiling point of iodoacetic acid is 208 degrees Celsius. Convert the temperature to Kelvin. Again, we're going to say temperature Celsius is equal to 208 degrees Celsius, because that's what they gave us. We're looking for the temperature Kelvin. Now, we know our equation we're going to use is temperature Kelvin is equal to temperature Celsius plus 273. Now, in our class, you don't have to memorize equations. All of these equations are given to you on what we call the pink sheet. Let's fill in what we know. Temperature Kelvin is equal to 208, which is the temperature Celsius, plus 273. Let's see what that is on our calculator. We have 208 plus 273. So I now have a Kelvin temperature of 481. Now, the rule on showing work in our class is if the calculation involves more than one number, you have to show work. You always have to show your work. Let's do one more problem. The boiling point of liquid nitrogen is 77.4 Kelvin. We're going to convert that temperature to Celsius. So what do we have? We've got the temperature in Kelvin, and that's 77.4 Kelvin. What are we looking for? We're looking for the temperature in Celsius. So that's our question mark. What's our equation? Our equation is the temperature in Kelvin is equal to the temperature in Celsius plus 273. Let's fill in what we know. Temperature is Kelvin. 77.4. We're looking for temperature in Celsius, and then we're going to add 273. So now, algebraically, I'm going to subtract that 273. When I do this on my calculator, I've got 77.4 minus 273. So my Celsius ends up being negative 195.6. And that's degrees Celsius. Again, Kelvin, lowest it can go is 0. Celsius can go into the negative. Fahrenheit can also go into the negative. Here's just a little picture that shows you the 3 scales. Again, you don't have to memorize the equations. We're going to give them to you. Okay, that's it for today.